Okay, in this video, video number 2, we are going to be looking at simplifying irrational square roots without a calculator. So no decimal answers. Okay, so irrational. First of all, irrational means when we take the square root of 18, there's not a number times itself that is 18. So irrational means you can't get a whole number when you take the square root of 18. You can't get an integer when you take the square root of 18. So we're going to have to utilize a method that's called the factor tree. So I'm going to take 18, I'm going to do a factor tree. So I'm looking for factors of 18. You can use any factors. You can use 2 times 9, you can use 3 times 6. Okay, I'll do 3 times 6. Now, 3 is already prime, so I'm going to circle it. But 6 is not, so I need to keep factoring 6, and that is 2 times 3. So the prime factorization of 18 is 2 times 3 times 3. Now, I like to write the prime factors in order, okay, in numerical order. Now, what we're looking for is we're looking for pairs or lookalikes, okay, twins, if you want to think of it like that. All right, so I see that 3 and 3 are a twin. So 3 times 3 we know is 9. So basically we can say the square root of 3 times 3 is 3. So that means 3 gets to come out of the radical, okay? Now, 2 does not have a buddy, does not have a twin, so it has to stay inside. So this answer is 3 square root 2. Okay, look at the next one for 50. Let's do a factor tree for 50. That's 5 times 10. 5 is prime, 10 is not, so let's keep factoring 5. So 2 and 5 now are both prime. Okay, let me just bring this down here. So the square root of 50 in prime factorization is 2 times 5 times 5. So again, we're looking for twins. We're looking for a pair of lookalikes. So 5 has a twin. So the square root of 5 times 5 is 5. Because the square root of 5 times 5 is actually the square root of 25, which is 5. So that means the 5 gets to come out. The 2 doesn't have a twin, so it has to stay in. Okay, square root of 2 is an irrational number, so we can't factor that down anymore. We can't simplify it anymore. It is the square root of 2. All right, let's look at the next one. The square root of 192. Ooh, big number here. Well, I know that 192 is even, so I'm going to start with 2. And that is 2 times 96, not 40. Now 2 is prime, so I'm going to circle it. 96 is also even, so it will divide by 2. 2 is prime. 48, we can use any factors of 48. We can use 4 and 12, we can use 6 and 8, we can use 2 and 24. I'm just going to use 6 and 8, so that's popular factors. Now 6 is not prime, so we need to keep going with the 6. Now 2 and 3 are prime factors. 8, well, it needs to keep factoring. 4 times 2. One of those factors is prime, but 4 is not, so I need to keep going. Oops. So that is 2 times 2. Okay, so both of those are prime. So, just bring this down a little bit here. Alright, so the square root of 192, I want to write down its prime factorization. Alright, how many 2's do I have here? Okay, well, I have 1, 2, 3, 4, 5, 6 2's. So I'm going to write 6 2's. And then what else do I have left? I have a 3. So I'll write down that 3. So I'm looking for lookalikes. Alright, I see that this 2 has a twin, this 2 has a twin, and this 2 has a twin. So the square root of 2 times 2 is 2. The square root of this 2 times 2 is 2. And the square root of this 2 times 2 is 2. Now 3 doesn't have a square root, so it has to stay in. So I have a 2 times 2 times 2 on the outside of the radical, and that is 8. So the square root of 192 simplifies to a radical form of 8 square root of 3. All right, hopefully you're getting this. I may have to make some more room for myself. 5 square root of 300. So let's first do the square root of 300. All right, 300 is 3 times 100. Now, 3 is prime. 100 is 10 times 10. I'll move this over a little bit here so I have some room. All right, now 10s are not prime. So 10 is 2 times 5. Those are both prime. This 10 is 2 times 5. And those are both prime. Okay, so let me just bring this down here. So 5 square root of 300. I'll write too big for this. 5 square root of 300 is 5 times, all right, so 300, what do we have inside? What do we have circled? We have 1, 2 2s, a 3, and 2 5s. So 2 2s, a 3, and 2 5s. Whoops. 2 2s, a 3, and 2 5s. Make that a okay, so let's look for our twins. We have this 2 has a twin, and this 5 has a twin. So the square root of 2 times 2 means that a 2 gets to come out, and a square root of 5 times 5 means a 5 gets to come out. Now, remember there was already a 5 out here, so we bring it down. All right, so this 3 doesn't have a buddy, doesn't have a twin, so it stays inside. All right, so let's multiply all these numbers here. That's going to be our number on the outside. 2 times 5 is 10, times 5 is 50. So this is 50 times the square root of 3. That is what 5 square root of 300 simplifies to. That's in simplest radical form. All right, one more. I've kind of left myself no room. Let's see if I can do this. All right, 75. Factor tree for it. Well, it ends with a 5, so I know it'll divide by 5. That's 5 times 15. 5 is prime. 15 is not. Okay, so 3 is prime, and so is the 5. So, let's see. Let me write it down here. Negative 6 square root of 75. So I have a negative 6 out here. Inside, I'm going to have 1 3 and 2 5s. That is what 75, the prime factorization of 75 is. So I'm looking for twins. All right, so I see that 5 has a twin. That's the only one that has a twin. Square root of 5 times 5 is just 5. So 5 is going to come out. Notice there's a negative 6 already out here, so that 5 is going to multiply by the negative 6. 3 doesn't have a twin, so 3 is going to stay inside the radical. So I'm going to multiply 5 times negative 6, and that is negative 30 square root of 3. So this is how you're going to do these in simplest radical form. That means no decimal answers. Do not use a calculator. Okay, so this is the end of video number 2. You'll now move to the end or the back of the notes and do the student problems again without the calculator. So show your work, show how you find the irrational prime factor trees for that.